This next part of your notes is just a checklist of things you need to think about when you are choosing the best model for your data. So number one, you always make a scatter plot and look at it. Which functions match the shape of the data? There might be more than one. If there's a certain curve, maybe you could do power, exponential, and quadratic, for example. Secondly, check the R value. You are looking to see if the R value is close to 1 or -1. Once again, you might have several possibilities that work, like in our example with the endpoint behavior. So number 3 is check the endpoint behavior. What happens as x approaches 0? For example, does the function include 0? Is that reasonable for your data? What happens as x gets very large? Is that reasonable for the context of the data? So that's what you're looking for. Are those values reasonable in the context of the data? Thirdly, or fourthly, use common sense. Which graph is most realistic in the context of the problem? Make a prediction with your equation and then check it. How accurate is your prediction? If it's not very accurate, you might need to try another model. Okay, the next section is what are the limitations of mathematical models? Number one, models are not an exact representation of reality. Mathematical models are never true, but they are often useful. It doesn't really mean they're false, it's just they're not perfect. A mathematical model will deliberately oversimplify reality in order to make sense of certain aspects of reality. But there are multiple variables that affect most anything in real life, and so a mathematical model is rarely perfect. There is danger in extrapolation, in making future predictions. A current trend may change at some point in the future, making that future prediction go awry, become less accurate. A model is only good if it can be replicated, which means getting consistent results with repeated trials. In other words, you do the experiment and I do the experiment and we get very similar results. A model is only good if it can be verified. In other words, the model makes accurate predictions. If the model doesn't make accurate predictions, it's pretty useless. If it is not accurate, if it cannot be replicated, the model needs to be refined or discarded.